So I'll keep this talk short. I know it has been a long evening and we have heard a lot of interesting topics. So I'll just keep it short. It's a practical talk. I quite like practical talks because I usually deal with some, side projects or something that bothers me and I try to solve it. So then I have the urge to share it. So thanks for your time and patience. Today I'm going to talk about dynamic structures in Kotlin, and it's a concise talk. I will keep it really to the point. So after a brief introduction into the project and the challenges I've come across, I will delve into what dynamic objects are, how to work with them, not only in Kotlin, and then I will go through all the possibilities that are in the language I found might be useful, and then share my own approach to building or using dynamic properties in my code. And obviously there'll be a demo, just to wrap it up, and space for Q&A at the end, but feel free to ask me questions throughout my talk. That's equally fine. All right, so the project I've been working on is basically Zoom SDK. For also, just to put it that way, I've done a lot of integrations lately, and one of the integrations was the Zoom platform. And for some reason, their API can be quite cumbersome and complicated. So I started to write a client that wrapped around some of the APIs. But then I decided to take it a step further and started to work on an SDK. And that's now open source. So the SDK, what it is, essentially it's designed to make it simpler for developers to integrate with Zoom meetings on desktop and mobile applications. Since I typically work solo, I use Kotlin multi-platform just for code reuse, and overall it helps me save a lot of time. But then there are also challenges that the SDK cannot solve on its own. And that's when I have to deal with inherently complex data model that's present in Zoom and decide how to map all the objects and fields to the classes in my SDK, and so that I support the broad variety of functionality there is in the API. And it's not a small feat because the Zoom specification, it's a sizable document, and the object it's full of large objects with a ton of fields. For instance, the base meeting objects has more than 100 base fields. So it's not easy to work with. And an obvious solution to that might be using a code generator. So take the OpenAPI specification and then a Swagger and just use a generator to generate the model classes. But then I found it also, it's full of complicated rules that are not easily supported by mainstream generators. And also, since I'm using the Kotlin multi-platform, the downside is that I'm limited in terms of which libraries I can use. So in the end, I decided basically to use a different approach. And I typically watch Netflix with subtitles on, so I sometimes come across quotes or sayings that are inspiring, that I find inspiring, especially when they relate to my daily struggles as a developer. So this one, when in doubt, leave it out. Yeah, so leave it out. If you're not sure how to use the model, if you're not sure about the semantics of certain fields and settings, then maybe it's not a good idea to try to represent it at all. And I, in the end, chose a different approach to the problem. And started to think about dynamic objects. What they are, basically, dynamic objects is an object that allows you to tamper with its structure. So you can add fields or methods on the fly. And languages like JavaScript are a prime example where you can just modify the object on the fly, add new properties. And this is how it looks like in JavaScript, for example. It's pretty straightforward. It's almost too easy because you can really do that. And obviously, there are no guarantees. There's no type safety. And if the code base is large, then it becomes messy very quickly. But it was an inspiration for what I needed. I essentially wanted to be able to say, well, this is a base, say, base event class. It has only certain fields, and then everything else could be part of some sort of a context, which I could then, in a type-safe manner, extract information from and use it in my business code. There's a different way also in JavaScript how you can do that, which is maybe more transferable to statically typed languages like Java or Kotlin, where the functionality is the same, but now I extracted the field definitions out of the actual class. So this person object now can still reference name and age. They inevitably are part of that structure, but they can also refer to these variables separately from the object. And that's something that I found interesting, and I started to explore a little bit more on that. But then obviously the question is, do we even bother? Because in languages like Java, statically typed, the object structure is set in stone by the class, so you can't add new fields, not even via reflection. So what would be the solution? And obviously, an obvious solution is using a generic map. When you could have, say in this example, instead of a person class with very specific fields, you could have an entity record, which is an ID, and then everything else is kind of like properties of type any. And you can construct, obviously, a person object out of that, and it'll print out nicely, but again, you don't have these guarantees about type safety. Serialization is another problem. You can't just serialize anything. You need to be very specific and even provide custom serializer, right? So it's not that easy. However, using map is easy in both Java and Kotlin. The syntax is pretty much the same. The benefits are just maybe the ease of implementation, but then the downsides are obvious. So you can't really reason about that, serialization, type safety, not to speak about things like which fields are mandatory, which are optional. And so I had to dig a bit deeper. And considered other approaches, like what else can I do? Reflection API, is hard to use and it doesn't really work in this context. Extension functions are great, I love them, but they can only extend on what's in there already, right? On existing fields and methods. And then you can get inspiration somewhere else, like Groovy, for example, has a kind of a dynamic bean called Expando, which is transferable to Kotlin. So I can, expired by Groovy, I can define this class, which is again based on a generic map. And then I can do something similar I was able to do with the JavaScript code. So now I can easily define new properties on the fly. But that's cool, but still has the same kind of a problem. And it's not just good enough. It's not good for what I wanted to achieve. So then, as a last resort, I explored the concept of delegated properties in Kotlin, where they're handy, they're unified way how you can introduce listeners or observe for changes in values. And incidentally, they also, one of the use cases is that you can store properties in a generic map, but you can access them in a type-safe manner. This is how it looks like. The person class now has, again, a generic map, but then it also has two specific fields that are backed by that map, and they are typed. So when I create the person, I can now access these properties and be sure that one of them is string, the other is integer. Obviously, nothing prevents me from putting values that are not compatible in the map, and that would again result in an error. But it's an improvement. So I tried to apply it to the concept I was thinking about earlier, as in extract the field definition outside of the class, because I don't want to touch the base objects every single time I want to support a new field. I just want to be able to have these definitions outside of the class so that I can use them in the context, but not necessarily they're not part of the class itself. And it compiles. I can do that, but then if I try to use it, obviously that doesn't work. And looking up a key that's based by string keys and trying to use an integer, it just won't even compile. So that was a no-go. So then I came up with kind of doing some research, and I came up with like custom approach to solving that. I created an interface called dynamic property. Obviously, it relies on generics. And it has a couple of fields inside. That the first one is name, so I can give my property a name. That's strictly speaking not necessary, but my use case was serialization because I wanted to be able to read JSON objects with structures that I don't know upfront or know very little about upfront. So I wanted to be able to access or define which fields do I want to access and define some assumptions about them in my code. Then there is this type represented by a K class, which essentially is of type T. I had to use a wildcard to make the compiler happy. And the reason is that the K class only works with non-nullable types. So I would have to, and I'm not given the compiler the guarantee that T is not nullable, so it won't allow me to use T directly here. I would have to extend any, but then that had other downsides, so I decided to live with that and enforce the verification somewhere else. I'll show that a bit later. And then there is the serializer. That's a big thing for me, so the ability to inject a custom serializer, just in case it's a custom object, which I need to write a custom serializer for. And there are two methods that essentially enforce box the generic value into the type the value is supposed to have. So one of them is casting. It's essentially quite a risky operation, and in the code, in the SDK, I use the cast operation only as the last resort. And then the default value then allows me to declare a default value. It's a function which I can provide to the constructor of the dynamic property, and that function essentially provides the default value if there is no value found in the JSON, say. That gives me the some of the features I wanted. So a stronger type, possibility to set a default value, and support serialization. With that, I was then able to provide a constructor, which in this case is like a factory method. I chose to use an inline function because I didn't want to use information about the actual type. So that's thanks to inlining and reification, I can now refer to T as if it was a normal class. So I can now enforce that the type is essentially of T type. And as you can see, the cast operation is pretty clunky. So if the value is not of type T, there will be an exception thrown, which is handled later in my code. And this allowed me to come up with some simpler methods that allow me to distinguish between required fields and optional fields. The distinction is that in the required field, if the value is missing, then by default it throws an exception that this particular field is required, whereas a nullable field returns null. And then essentially that's it. In summary, that gives me the dynamicity I need to be able to declare properties with particular types and behavior. It has serialization support, and I can now use it in my SDK. And the use case I was trying to solve with that were primarily webhooks. Another use case would be API calls, but say there's a lot of webhooks requests in the Zoom API. There are over 130 different events with some common structure, but also large variety in terms of the payload. And some of the payloads can have quite complex fields. For instance, if there is right now we're recording this meeting, right? So once the meeting is over and there is an application that's signed up or listens for the recording completed event, then what it receives is about, will receive information about the recording, and that will be about 40 fields with some nested objects in it. All right, so so webhooks are complex, and what I did, we spoke about DSL earlier, so that's exactly what I did. I created some sort of a DSL for webhook handling. So each webhook handler can comprise multiple events, like meeting ended or meeting participant joined, recording completed, etc. I can add these handlers, and inside these handlers, I'm then able to use these dynamic properties to essentially reason about what's expected in the payload and then extract that information from the payload without having to have a specific data class for that particular payload. They come in two flavors, the webhook handlers. One is DSL and the other is what I would call a classic style. So the DSL is more for people who like to use frameworks like Ktor and they're not offended by using DSLs. The other one is more like traditional, like Spring or Micronaut, when you want to create a class and then call its methods, but it's just a matter of choice. So anatomy of a webhook handler very quickly. I think this is the last slide before the demo. So there's the error handler, obviously, because if you think about it, the webhook handler, it receives an event. That event needs to be validated, needs to be deserialized. It's inspected. There is certain expectations, so anything can fail. So there is an error handler which essentially catches the exceptions and allows you to send the failed request to DLQ or log or send some metrics. Then there are these event handlers, which essentially they are for your business logic. And these event handlers can now use the dynamic properties to extract information from the payload. And you can then use them for your business logic, like writing to database or communication with other APIs, etc. And there is this trigger, which is, so I construct the handler and then I can call the handle the particular request, and that triggers the entire flow. Right, so demo time, very quickly. I've created this short demo where there are two events. Hope you can see it. Yeah. One represents the event that's sent when the meeting ends, and the other one when participant joins. And you can see some commonalities, like each meeting has a name, obviously, timestamp, and a payload. And inside that payload, there typically is account ID, that's fine. And there's this object, which is also a common property. But then within the object, there can be anything. In one instance, there's just like primitive types, nothing interesting, maybe some dates. In the other case, there's this nested participant object, which is something my SDK is totally not aware of. It doesn't know anything about these events. So the way I start essentially is, maybe I can delete this. Oh no, I'll just leave it. So I use the DSL for defining the webhook, and then this is the error handler, which then takes the incoming request that fails, whose validation or working with it failed, and also gets the exception, which then I can use for login or whatever I want to do. Then there's this handler, which specifically deals with the meeting ended event. And then inside that handler, I have got this on event method or DSL that is triggered only and only if the event is valid. That means the event most likely contains all the fields I want, and then I can work with them. And now in the local scope, I can now declare these dynamic properties. I can say, well, the event class itself never has anything like a UID. That doesn't exist. But I can say, well, I have read the specification. I understand as a developer what meeting ended does, and I know it has the UID field. And I know it's required, it's mandatory, it must be there, so I will just add it to the context as a required field of type string. And then I can access it. I can access it through the events context as UUID. Similarly, I know that the event must contain a start time, which is of type instant, and I can choose whether it's going to be a Kotlin instant or Java time instant. So if it's a Kotlin instant, I should not need a custom serializer. That should be serialized out of the box. Let's try. Yeah. So that's extracted the expected fields and also interpreted the date as instant. But then if I choose to use Java time instant instead of Kotlin ones, then I do need a custom serializer, because without that, it would fail. So now I need to add this instant serializer, which I have available in the SDK, and again, it's interpreted correctly. Similarly, with this other event that contains the nested participant object, what I can do as a developer who's using the SDK is I can, again, create a data class that represents the participant in my world. I only extract the fields I'm interested in, and then I can create event handler that deals with this particular event. So let me just quickly do that. I will add a new handler. Then I can, and I can declare the participant field is of type participant, and then with serializer participant serializer. And I have it accessible because I'm using Kotlin X serialization. So because I marked this data class as serializable, the serializer is available to me, and I can then use it in my code. Sorry, let me just print it out. Oh no, it obviously won't do anything because I need to still handle that event. Participant joined. Yeah. So if I call it, I can see that I received the data class participant, and I can even in my code I can just access its properties, and so it's like type safe. I can work with that as with the data type that it's supposed to have, as opposed just a string and then trying to cast it. So yeah, that's the concept I've recently introduced in the SDK, and I'm experimenting with it. And I think, speaking of benefits and drawbacks, this is something that's primarily driven by me not having time. Me working solo, I don't really have time capacity to add tons of different objects, and the code generator didn't really work. So that's why I'm doing this. Whether that's going to be a viable approach going forward, we'll see, but so far it looks promising. The benefits are obvious. I already talked about them: the data type safety, serialization. But then obviously the disadvantages. Again, serialization is a big one because it won't work out of the box, and you might need to write your own serializer, or the SDK might not have the serializer you want, so that's a bit of a hassle with that. And then errors, they can still occur because you might make false assumptions, and then the payload actually doesn't comply, and then you will deal with errors. That's why the error handling is important, and it needs to be rock solid. And then also a little bit of an overhead, because it's not a big deal, but you still like using these not that trivial objects like dynamic property, dynamic context everywhere. So there's a little bit of overhead with that too. So yeah, that's just quick thoughts on what I've been doing lately, and I hope it was somewhat relevant. Thanks for your attention, and now it's time for questions if there are any. Thanks.
The use case is that you're writing the SDK, and you want to let the consumer of your library to add.
Decide, basically.
Yeah, to specify some additional properties. So, why I'm not being expert in that area, have you considered to use some like code generator for that, like
That's what I said.
Some Kotlin symbol processor based solution or something?
I wasn't even sure if that would be the right approach, because then I would end up with like large data models or like classes that have a lot of fields, and there probably wouldn't be like a lot of guidance on what these fields mean, how to use them.
No, I'm sorry. Maybe you don't understand each other. Just to provide the support for the consumer of our library to hook symbol processing in this project to, based on the configuration or something, to generate just the properties he actually wants.
Oh, okay. No, that's a good idea. Yeah.
Very generic idea. Not really sure if it could work somehow.
I think no, it's aligned with my objective, so I might as well explore it. Yeah. Thank you. Thanks.